All right, so far we've been looking at these indeterminate quotients. 0 over 0 form, infinity over infinity form. And for those, we saw we can use L'Hopital's rule. Now, there's other indeterminate forms that we can consider. And next, we're considering indeterminate products. So this happens when we have a function times another function. And the form here for an indeterminate product is 0 times infinity. All right, so we're calculating the limit of a product of two functions. How do we get this form? Well, one of those functions, in this little definition, f, goes to 0. And the other function, in this definition, g, gets really large positive or really large negative. So it goes to positive infinity or minus infinity. So if we have a product of two functions, and one of those functions goes to 0, and the other one goes to infinity, well, then we have an indeterminate form. And why is it indeterminate? Well, if one of our factors is going to 0, it wants to make the whole product really small. So if our function f of x, if that wins, then the product goes to 0. The overall limit goes to 0. But g of x wants to get really big. So if g of x wins, well, then the overall limit goes to, plus or minus infinity. Or those two functions that are in competition, they might sort of balance each other out. And that's always a possibility. And what might end up happening is that our product just approaches some number in the middle there. So that's kind of the general idea with these indeterminate forms, just generally, is that we have two pieces of our function, and one of the pieces wants to do one thing, the other piece wants to do something kind of almost the opposite, and they're in competition with each other. So for this indeterminate product, if this first term wins, then the whole function goes to 0. If the second term wins, then the whole fraction gets really big, or maybe they sort of balance each other out. And that was the same thing that we saw with fractions, with the quotients. Does the top term win? Does the bottom term win? Or do they sort of balance each other out? All right, so we have this definition, this 0 times infinity form, and we've written it for these limits x approaching a, but similar definitions exist for right, left, and x approaching infinity and x approaching minus infinity. So standard kind of thing there. All right. So how do we handle these indeterminate products? Well, our strategy for a lot of them is to try to rewrite our product as a quotient. Normally we don't like to do that because normally if we can get rid of fractions, it's a good thing. But we know with quotients, then L'Hopital's rule might come into play. And so there's two options. When we look at a product here, we have f of x times g of x. We can kind of artificially create this fraction. And one way to do it is we can take our function f and divide by 1 over g of x. Or, if that doesn't work, we can take our function g of x, put that on top, and then in the denominator, we can put 1 over f of x. So we're kind of doing like two reciprocals here. So really, these take us back to where we've started. They're kind of artificially creating these fractions, though. And so if f is the thing that's going to 0, in this case, the top term would be going to 0. And if g is the thing that's getting really large positive or really large negative, then this is a c over infinity form, so that goes to 0. And 0 over 0 form means we can use L'Hopital's rule. So that's always nice. This 1 over g of x, if g is going to infinity, then this is a c over 0 form, or c over infinity form. All right. Well, now what about the other option here? We have our product here, and now we're putting g on top. Well, what happens? G is approaching infinity, getting really big. And then what happens to 1 over f of x? Well, f of x is approaching 0. And so we have a c over 0 form down here. And c over 0 forms are infinite. So we have, in this case, we have another one of our indeterminate quotients, but it's of the right format, so we can use L'Hopital's rule. So in each of these, we're kind of converting this indeterminate product of 0 times infinity into one of our good indeterminate quotients that allow us then to go on and use L'Hopital's rule. And just a reminder here, this 1 over f of x form is a c over 0 form. That's why we're getting its infinite. So that's why we got infinity down here. It was a c over 0 form. And that's the same reason why down here we got a 0 is because that was a c over infinity form. All right, so it's going to help to try an example with this, but we're just kind of setting the stage. We have this indeterminate product, and this is going to be our main kind of strategy for dealing with those indeterminate products.